and I can just announce the last speaker for this session, who is replacing Yuri Tomishek from GISAT, but we have Arul Sivasankar. Sorry for if I pronounce your name not well, but you will present the EU Grassland Watch project. Thank you.
Mm-hmm. Okay, I didn't know about the audience that I'm going to have, so it's going to be a bit specific because we created a presentation on how we use OpenEO platform and what we have developed so far, and I'm going to present two of the specific cases here. So the project that we are working on is EU Grassland Watch. This is a project from the European Commission, and the main objective of the project is to monitor most of the grasslands in Europe, which is also part of the Natura 2000 site. So we have a large area to monitor, and this is extension of a previous project which was called the COP4N2K. And the aim of this project is to develop on the existing methodology that was developed in the previous project, and also use the OpenEO platform in cooperation with Vito, and also use as much as possible the existing data sets that's available within the Copernicus data set. So these are the partners who are working in this project. So the organization that I work with is GSAT, and within for CDSE, we are working with Vito. So this project has several components. First is identifying the grasslands, and then once we identify the grasslands, we want to categorize the grassland into different types, like alpine, wet grassland, dry grassland, and so on. And then also monitor the grassland management that has been done so far. And we want to do wall-to-wall, as I think, I'm not sure of the beginning here, but until now, and also make it operational and also accessible, easy access by the users as well. So we split the projects into, let's say, several steps. The first step is grassland identification of the grasslands. So this is the first use case that I will present here. So this is the first one of the test results that we got so far. And what we want to use is the data that is available within the data space, which is the Sentinel-1 data, Sentinel-2, and some of the elevation models that we have. And also we also have some external data sources that we wanted to use. And then this is the second step, where once we identify the grassland, we want to categorize it based on the type of the grassland, like dry grassland, alpine, wet, and so on. And once we have these types, then we would monitor, see what are the management event that has happened so far, and also the productivity. And this, we will use the HR VPP, which has also been made available within the data space. Now I'll present the first use case. This will be very specific to how we implemented it. The aim is to have a binary mask of grassland and not grassland. In the previous phase of the project, we had to create process all the EO data and store it in our own infrastructure. But within Vito, now it's easy because we don't have to process any of the EO data. They process it and give us the final data that we need. So the first step is we took the training sites from the Lucas dataset, where we know the areas where the grassland exists. And then we distributed some points, training points within these polygons. And then we defined the data cube that we want. We used different bands in the S2, different bands in S1, and some of the topographic features like elevation, slope, and aspect. And what we did was we were able to just tell the OpenEO that we need this data cube, and we need for these specific training points the information of these data cube. And they also have developed this OpenEO GF map, with which you are able to create these training points. Also create, split these training point into small batches and then submit it into OpenEO, because instead of submitting it as all the training points in one big batch, you can split it into batches of 50 training points and then submit it. And in the end, after processing all these EO data, you get in a nice CSV format in different columns, over several months, what the information about the timeline of the different bands, for example, we have here 6 bands in the Sentinel-2, so we have for each month all these 6 band values, and then these 2 Sentinel-1 bands and so on. And now we did offline training using random forest method, and then we created a machine learning model, which we saved into this ONNXS format, and then we uploaded it to a publicly available URL, which you can directly download it. And then we were able to tell OpenEO that we want to use this model for prediction for a given area using the same data cube. And once you send the tasks in the model, you are able to also monitor the tasks as it is running. And they also have an option, once the task finishes, there is also an option to view the results directly there, or also download the TIFF files and see it. So this is the final Grassland mask, final land cover classification that we identified, and from this, we are able to create a mask of grasslands. So this is the first step, which has already been developed, and we are testing it in production now. And then we moved on to the second task, which is identification of the grassland types. This is a bit intensive, and we are still in development because there are a lot of grassland types, and the data cube for each data cube is a bit different. It is still in development, but I will just specify one case, which is identification of the alpine grassland masks. Here, what we wanted was, there was one data set that we wanted, which was not still part of the ecosystem. So what we had to do was we had to upload it to Cloudflare and then create a stack from it. And then we were able to tell OpenEO to use this stack for our process. And there is also this existing elevation model that we were able to use. So in this way, we are able to combine an external data source and also what is existing as well. And with this, we were able to work with this. So for alpine grassland mask, what we wanted to do was we wanted to identify those grasslands which are in the alpine region. Like you have these, up to a certain area, you have the forest and then you have the grassland. So what we wanted to eliminate was those grasslands that would occur below this elevation where the forest elevation stops, because whatever is above should be classified as the alpine grassland. So this is the elevation model, and this is the HRL layer that we used to do this. So we have it. We were able, just by telling it to apply some simple thresholds, we were able to identify the alpine zone, which is where the forest ends and the grassland starts. And we were also able to classify forest and non-forest, non-forest areas. And the non-forest areas are what we consider as grasslands. By combining these two, this is the alpine forest and this is alpine grassland mask. We were able to, using simple threshold, identify these areas. And then what we did was we were able to aggregate some information on polygon level. We were also able to aggregate some information on pixel level. And just by comparing the like the pixel of the forest, like with the highest elevation, and the elevation of the grassland. We were able to compare it and then classify it whether it was alpine grasslands or not. And then we were able to create this mask. Yeah, and this is where we have stopped so far, and we have to create such workflows for other type of grasslands as well. And yeah, this is a work in progress, and hopefully we'll have all the results that we need. And that's it. Any questions?
No questions from the audience? No. Thank you very much for your clear explanation. That is, thank you.